With Nagaro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
Hey folks, how's it going? Welcome back. Welcome back to the second talk of the day. I'm Shayan. I'm one of the organizers of Chaos Carnival, and it's my pleasure to introduce our next speaker, Karthik. He's one of the maintainers of the CNCF incubated project Litmus Chaos, and with a passion for all things Kubernetes, he is generally interested in DevOps, storage performance, benchmarking, and of course Chaos Engineering. So yeah, please join me in welcoming Karthik to the stage. The stage is all yours.
Thanks, Shine. Very happy to be here. That was a wonderful keynote from Adrian. Really enjoyed it. That's a great beginning for the conference. So let me go ahead and share my screen. I hope my screen is visible.
Yep, seems good.
All right. So thank you for the introduction. Very generous of you. So let's talk about traversing the cloud native dependency pyramid. I think that's a very long name or title for a presentation. We'll see what it means. Again, I think Shine has already covered it. Let me go ahead and get into the agenda. So, in the keynote, you might have heard about why chaos engineering is important. What are the obstacles to start chaos engineering? Where does the push need to come from? How do you approach chaos engineering as a process? A lot of good info. So, I'm assuming that by now you're all clear about the relevance of chaos engineering and how you actually get started. There is a problem though. We'll talk about very similar concepts as to what was referenced in the keynote in this discussion as well. But we'll go one step deeper and talk about some operational aspects and challenges that you have with chaos engineering and how you go about solving that. So, as part of the agenda, we have these items today. We'll talk about the big conundrum that we have, where to start, what kind of chaos experiments to start with. Of course, all this comes after you've identified the why as part of your management and as part of the engineering team. You've identified and justified for yourself why you want to do chaos engineering. And once you've decided to take that step, the next problem is about how you approach it. What is the kind of attacks you need to carry out, where you need to carry those attacks out, and what components or which services do you do the chaos, right? And there has to be some intentioned reasons behind doing that. When you're picking something, you need to be very sure of why you're doing that. And we'll talk about what causes this challenge. So why do people have this challenge? Why do they have this issue in the first place? There are so many kinds of attacks. There are different kinds of components where you can inject, which you can subject to chaos. But the problem is compounded in a cloud native environment. So in this discussion, we'll focus on chaos in the cloud native context. Of course, chaos does not need to be restricted to a cloud native or Kubernetes native environment. It is applicable for all kinds of applications and infrastructure. But of late, a lot of organizations are undergoing digital transformation. They're moving to cloud native ways of building, hosting, and maintaining their applications. So we'll talk about chaos challenges in the cloud native context. So once we've identified the problem, we'll talk about potential solutions. How do you start addressing this, and then how you go about implementing it, right? And the solution that we're talking about or introducing today is lineage-driven chaos injection, as seen from a deployment lens. The concept of lineage-driven fault injection or chaos injection is not a new concept. It has been around, but it has been very focused on application business logic. We'll talk about it from a deployment lens, right? And then we'll talk about the aids that you would make use of to implement the solutions that we're talking about. So to summarize the objective of this discussion, It's just seeding some thought into your minds, just some food for thought on how to approach the operational aspects of chaos experimentation in cloud native environments, right? So with that, sorry, let's jump into the what. So you might have, once you decided to do chaos engineering, you might have started taking a look at the various tools in the ecosystem, the different kinds of frameworks that are available, open source, enterprise solutions, etc. And one of the things that you're faced with is the sheer volume of fault types. So we are using this term fault and experiment interchangeably. Ultimately, it's the chaos experiment is that it is an experiment. You're learning something new about your system, but in the process of experimenting, you're injecting faults, and then you're also validating some hypotheses. So just to keep the discussion fluid, we'll use the term fault and experiment interchangeably, though that might change from tool to tool the way it is looked at. Right? You have different kinds of faults or attacks or experiments that you can do. There are a few on the screen. Majorly, the categories can be about network-related faults, injecting latencies, injecting packet drops, corrupting your packets, duplicating your network packets, causing network partitions, things like that. There can be state-related chaos when you're actually manipulating state of the service or infrastructure component under question. You're turning it off, you're doing shutdowns, you're doing resets, all those kind of things. You're taking it down for maintenance. And then there are resource issues or experiments. What happens when CPU or memory or disk or your network bandwidth is like basically getting eaten up? And what happens when there are configuration issues? There was some kind of a configuration drift on your cluster. There was improper configuration. Maybe you did not put the right secret, you did not provide the right timeouts. Then there are security issues. Maybe you have the improper security group configurations. You've probably opened ports that you should not be, things like that. You have improper firewall rules. Then, of course, there are other kind of attacks, load attacks. You can be causing denial of service kind of situations by stressing the system with too many API calls, for example, things like that. So there are different kinds of attacks. And all these attacks are going to be applicable in equal measure to the infrastructure or the applications that you're looking at. So how do you prioritize? How do you assign an attack to an infrastructure component or to a service? And how do you go ahead and execute that and prioritize that over the other, right? That's really the confusion that you have. And then you have, just like the different kind of attacks, we already alluded to this by talking about it in the previous slide. The where also is important. There are so many kind of components that make up your eventual deployment environment. So when you are providing a service to the world, to the customers, there are so many components involved, right? You have your application primarily probably deployed as containers. You have your own application divided into several parts. Right? There's the middleware, the front-facing part of it, the backend, and it is all hosted on some infrastructure. Right? You have EC2 instances. Maybe you're on AWS. You have load balancer configurations. Maybe you're using third-party dependencies. You have maybe you're using Mongo Atlas, or maybe you're using some third-party storage appliance for your disks. And then you have issues, or you have infrastructure fault lines within what you've already created as clusters. For example, the cluster network might go down. Maybe you're using some managed services like Lambda functions. Maybe you are running your own services as Kubernetes deployments. Maybe you're running some Spring Boot applications. You're running some Python applications. There can be issues within the software as well. So there can be issues in infrastructure. There can be issues in the software that you are deploying. Then there can be issues with third-party dependencies. There can be so many components which can be subject to failure. And you talked about the different kind of attacks. Now you have so many kind of components. So how do you do the mix and match, right? And how do you actually prioritize? So that's really the confusion. We'll dig deeper and see why. We'll try to understand how this sort of comes about in a cloud native environment. In a legacy or a heritage infrastructure with monolithic applications, you probably might not have faced so much confusion. But it is really something to look at in case of cloud native environments. So you can look at this dependency pyramid here. You have the platform or the infrastructure that is maybe on some cloud provider, or maybe it is in your own data center on-prem. You're putting Kubernetes on top of it, which is a very, very dense system in itself. It's a very dense orchestration engine with multiple moving parts, multiple services that makes it function. Then you're pulling in a lot of services from the CNCF landscape, from the Cloud Native Computing Foundation landscape, as auxiliary or supporting services. Maybe you're using some service meshes, maybe you're using some monitoring systems, maybe you're using some service discovery mechanisms, etc. These are, when we call this as auxiliary or supporting, don't get me wrong, these are very important for your application to function, your services to be available and usable for the customers. But that's something that you are not controlling, or you are not really sort of writing. This is not the application business logic that you are involved in. This is something that you've pulled from upstream, right? And you may probably have enterprise variants of these services running, but still that does not rule out any resilience issues within them. Then there are direct application dependencies, right? You have databases, you have message queues and whatnot. And then you have your own application, which is probably a set of several deployments, several microservices. Like I said, there's middleware, there's front-facing solution, front-facing services, your websites and things like that. And then, of course, there's the backend, which interacts with all your lower areas of the pyramid, things, your backend that speaks to your databases, and that is involved with your service discovery and things like that. So each of this, some of these have a direct impact on your resilience, and some of these have an orthogonal impact. What we mean by that is, let's say your monitoring system is not working well. If at all there is an actual problem, a fault that you saw, an outage that you saw, you're not notified about it, and you're probably not in a position to take action at the right time, which is a big problem, right? Some of these are indirect dependencies. And within your cloud native environment, you can visualize this pyramid being, a set of several deployments inside of your clusters. Each of them has its own deployment cycles, right? You have DevOps teams which are trying to deploy at a very fast pace. You're probably doing 10x deployment speed than what you used to do, let's say, a few years back. And each of these have multiple entities within them. For example, we're talking about platform services that can involve compute nodes, that can involve storage, that can involve network. Talking about Kubernetes, we're talking about several services like Kubelet, maybe your runtime, your schedulers, etc. You're talking about Prometheus. It has its own exporters. It has the Prometheus server, and then it probably has your other components running your dashboards, etc. So at each of these layers, you have several entities, and each of these entities need to work well and need to be working at optimum performance for you to be able to say that your system is resilient and your users are getting the right kind of experience, right? That's really the dependency pyramid that we have in the cloud native environment. So when, as SREs or as DevOps folks, when you're faced with this kind of infrastructure challenges, how do you ascertain what kind of chaos experiments that you will do? You could be thinking of past outages, things that you saw failing before, and you might want to test them out and prevent them from happening again. Then there might be some hints that you get from functional or performance tests. Your QA team is actually telling you that I see something amiss in this particular service. We need to subject it to more failure testing, right? And then, of course, there are developer suspicions. Maybe somebody decides to do random exploration of your infrastructure. And then, of course, you have architecture walkthroughs. You have your architecture diagram, your deployment diagrams. Then you're coming and walking through it to see what all failure points are there, and then you sort of list them, right? But architecture walkthroughs are very daunting, and they are very subjective as well. Depends upon who is sitting for the architecture review, right? You may not have the quorum, you might not have the right folks, so it can be, it has its own challenges, right? So you can see this picture there. Is it enough? You need a very scientific approach to deriving the proper set of chaos experiments, what attacks to do, on what components, when are you going to do it, how are you going to repeat it? Are you going to do it continuously? Are you going to do it in a one-off way? What are you going to validate when these chaos experiments are being executed? When the fault injection is happening, what is it that you want to validate? All this needs some scientific approach to arrive at this list, right? So the solution that we are sort of that I would like to propose or sort of seed the thought into your minds is something called lineage-driven chaos injection. And we are going to look at lineage from a deployment perspective. So we're taking a two-pronged approach to identifying the lineage. One is see what is the composition of your service, right? And when I say service, I'm just talking about an entity which is probably listening. This is the standard definition of a service. It's listening on one or more ports. It's backed by a workload or a process, right? Try to identify what is the composition of the service. What are the backing resources? Okay, this is probably the deployment or the stateful set or daemon set behind a service. These are the pods comprised of your deployments. These are the containers within your pods. These are the processes running within your containers, right? Potentially each of this is a failure point. Maybe some of them can be prioritized, some of them need not be, right? And some of them are not really targets. For example, deployment is not really a target in the truest sense. Ultimately, it's the pods that are going to be impacted and the containers that are going to be impacted. But you would need a wholesome picture of what is your service looking like, what are the checks, health checks associated with it, and how it is deployed in your environment. So there are some diagrams that you can see here, which are actually helping you to visualize this. There are deployments that are spread across, which have replicas spread across nodes, right? Each of them hosts some pods. They have containers, and then there are process, and then they just repeats. So you identify this list. That's the first thing that you would do. And then you're also looking at what are the dependencies for a service, right? And you take why are we focusing so much on services? Because ultimately these are the functional or the this are sort of really the brains as part of your entire application infrastructure. And these are what are combining to give you the ultimate usage, right? Ultimate customer service. So which is why we are focusing on these as the main nodes in our identification process. The second approach, the first approach was about identifying the composition of a service. The next approach is about identifying what are its dependencies. So I have shown you a sample e-commerce application. It's an online boutique. And what we have drawn here is the network map of that particular application. So we are saying it is composed of these microservices, the front end, the checkout, the payment, email, shipping, so on and so forth. And for each of these nodes that you see in this map, some services are upstream and some services are downstream, right? And sometimes the upstream or the downstream might not be within the infrastructure that you are hosting. It might be outside. For example, let's say you're using some managed Redis or managed Mongo. That's something that's sort of residing outside of your cluster, right? But of course, it's an important element that you need to factor into and find out what chaos you can do for traffic that's going out to this managed services like Redis or Mongo, right? Sometimes you might want to get a view of this network map for your entire cluster. That's basically going to be complicated. It's going to give you a lot of chaos that you can do, but it's going to also muddle your view. So it is good to do this for certain logical boundaries. The logical boundaries can be your application, or maybe it's for your team. It's the part of the your infrastructure that probably you're responsible for, etc. So you create this logical boundaries, do this mapping. So at this point, what you've arrived at is a service catalog. So you have a service, you have a detailed idea of what it is doing, what are the APIs that it is supporting, what is its steady state optimal characteristics, what are the service level indicators of your service, what are your objectives around its functioning, right? What do you expect about the service? How performant do you think it should be? How much availability do you think it should exhibit? All that, and then you have all the backend resources behind that service, and then you also know what are the services that it is speaking to, what services depend on this service, what is the hosting infrastructure underlying it. Then of course you also find out about what's happened to this service in the past, what is the behavior it has exhibited upon certain conditions, upon certain traffic, for example. And then based on all that, you derive a priority. Right now, you have a list of exact chaos experiments. You have, let's say, attacks that you can map to all the backing resources. For example, state chaos can be done against the pods, against the nodes, Network chaos can be done against the services. For example, service A is talking to service B. So what happens if you do latency injection between service A and B? What happens if you do it between service A and C? Things like that. So you can identify the different kind of attacks, and you can map it against the different components that compose of a service. And of course, you can also do dependency related chaos, network chaos, latency injections, packet drops between certain services, or maybe what happens if an incorrect HTTP response is received for a service, or what happens if the DNS resolution doesn't take place very well, right? You can basically do dependency chaos, and then you can also say what happens when my service is getting loaded beyond a certain point. So you can do load tests and resource tests to identify all possible chaos experiments against a service. And then, of course, depending upon the practical challenges in being able to execute it, you might have time constraints, you might have tooling constraints, you might have environment constraints, cost constraints. There might be so many challenges in actually carrying out an experiment. Once you have this exhaustive list in your service catalog, you can always prioritize it and make a decision on how you're going to treat this, which are you going to take up, let's say, before the other one, and how are you going to fit that inside of your release cycles, your application delivery, or your application delivery plans, right? Some of them you might choose to do offhand, some of them you might choose to add it into pipelines for continuous runs, some of them you might choose to not execute as part of a given release, you might do it as part of the next release, etc. At this point, when we are talking about the service catalog, I'd just like to highlight the fact that the SLOs are very important. Doing fault injections is not that big of a deal. You can always find tools to do that, but it's always important to identify what is it that you want to measure when you're doing the fault injection. And this is the best way for you to actually write that down and be clear in your mind as to how you're going to approach your experimentation. And once you've identified the list, now you're actually proceeding into the chaos experimentation process, the execution process. And there needs to be certain aids for you to carry out chaos in a safe way, in an effective way, and in a way that gives you the best results or the best insights about the resilience of your complex cloud native environment. The first, I've just mentioned four aids. There are more, but these are probably the most important things that came to my mind. One is the guardrails and the safety aspect. When do you inject, right? What are the lean periods, or what is the right environment that you're going to select? Is it the pre-prod, is it the test environment, etc.? When are you going to stop? You might want to have some dead man switches, some automated ways of aborting your experiments based on certain thresholds and certain controls. What are the permissions necessary to carry out this chaos experiment, and who has those permissions, right? So these need to be defined. Then you come to the blast radius control. This is about trying to start small, trying to ensure that the experiments that you're choosing from the list are the ones that are effective and important, but at the same time don't have such a blast radius that there are a lot of people impacted and there's a lot of people burning their fingers, right? You don't want everybody to be impacted as part of the experimentation process. So lowering it down to the specific instances. Let's say you're not doing a global black hole for a service. You're only doing the disruption of network between a certain set of services. You're only disrupting traffic between two specific services to see what is the behavior. You're going one variable at a time, right? And then what is it that you're going to validate? And oftentimes the validation needs to be automated as well. There are tools that offer you this ability. It's important to ensure that you're not missing out, and which is why it is important to automate. Maybe if you're doing a manual check, you might be missing on certain parameters. As part of the service catalog definition, you've identified multiple things to validate as part of a hypothesis. And those things need to be the only way for you to cover all of that would be to automate it, right? And then at the end of it, you need some metric. You need some way to quantify your resilience, right? There can be different ways of scoring. Adrian in the keynote talked about resilience scores. There's one notion of resilience score which we use in the Harness platform and in the Litmus Chaos open source project. So you can identify different probes or different validation constraints for a fault, and you can have weightage for faults, and then you get an average, weighted average of what is the probe success percentage, and that gives you some kind of a resilience score, right? This is how tolerant your application is to this particular chaos scenario. And then you sort of take that forward and you map resilience scores at service levels, you map resilience scores at application overall application level, and then you also come up with metrics that measure the resilience of the team that's sort of behind this application, right? So with that, I'll probably like to conclude. I think we are right on time in terms of this presentation. So I just wanted to see some thoughts on what are the challenges that you would generally face in a cloud native environment in deciding what kind of chaos to do. And we've proposed some solutions on how to arrive at that list and prioritize. And then we're actually carrying out the experiments that you've identified from that list. What is it that you need to keep in mind, right? So that's a quick uh, presentation. So are there any questions that I can take?
Yeah, definitely. Awesome talk. It's certainly very interesting and must stir up a lot of conversations if you're trying to do this on services per se. But yeah, let's share some of the questions a lot of our attendees had. So the first one being with Julio, he wanted to know
Mhm.
if there are any compliance use cases for chaos engineering. If you could share your thoughts on this.
Yeah, that's a great question. Yes, one of the things that you would want to measure as part of chaos experiments is compliance in terms of security, compliance in terms of your data storage policies, compliance in terms of what is allowed to be done on certain infrastructure, right? You wouldn't want certain operations to be carried out on certain infrastructure components by the team, so you might want to measure that. Are you having the right checks, right security controls within your team? And of course, there are other kinds of complaints, actual complaints use cases. We're probably talking about, let's say, how is your data maintained? Are you able to access data where you should not be accessing them? Is your data persistent for beyond a certain period of time? Do you have the right notifications and monitoring? Do you have the right kind of incident response mechanisms tied in with your production systems? All that can be validated as part of chaos experiments. So these are, like I said, the orthogonal requirements that comes with your production deployments. This is probably not so much about the uptime as it is about what can be done on your infrastructure and what needs to be the attributes of your infrastructure in terms of data and security, etc. So you can definitely create chaos experiments for those kind of scenarios.
Got it. Makes sense. Cool. I think due to shortage of time, we can just take one more. So Anusha asks if you can design how you can design your own custom chaos directly if there are no direct chaos induction methods, and if you can, then how can you combine two or more of these chaos types?
That's a great question. There are frameworks that allow you to do precisely this. I can, for example, name the Harness Chaos Engineering platform. It offers the ability to string together faults. There are like more than 100 faults that are available. You can basically string them together to form the scenario that you'd like, the experiment that you'd like. But it also offers an SDK where it will help you to bootstrap your chaos experiment. Your chaos experiment has a standard structure. Typically, like I said, you have some pre and post chaos checks. You have the fault injection business logic. You have some eventing that happens as part of the chaos experiment. You basically have some validation that can happen depending upon the resource being targeted for chaos. So all this is part of the experiment. And there are SDKs available to help bootstrap this experiment. So you just need to fill the fault injection business logic, right? So that's available, and then you can store them in chaos artifact sources called chaos hubs, and then share it across teams. Having said that, I'm sure that there are similar capabilities that are probably available in other tools which will help you to write your own chaos by means of SDKs, or probably by means of separate scripts that you can use, things like that. But most of the times, many tools, any tool that you're picking up will come up with a basic set of attacks that will satisfy most of your initial cases. There are very specialized cases, that's when you would have to create custom faults. But most of the time, it's all about taking the attacks and stringing them together to form the right kind of scenario, or the right kind of sequence that you would like.
Got it. Makes sense. Cool. I think that's all the questions we can take. If you have any more questions, you can join the Chaos Carnival Slack channel, the particular workspace in the channel. Then you can ask them there. You'll also post these questions there. And yeah, thanks a lot, Karthik, for joining us and sharing such insights. And yeah, I hope you guys had fun. Stay tuned for the next talk and